Okay, so in 10.4, they're going to talk about adding and subtracting things, and they're going to talk about multiplying and dividing. And the one key thing I want you to remember about all of math is that when you add or subtract anything, you add or subtract what's alike, and then what's alike stays alike in the answer. And so like back in the beginning of algebra, you learned how to say 4x plus 7x. Those are like terms because they have the same letter and the same exponent. But since they had the same letters, you could add them. You would add the 4 plus the 7. And then what's alike was the x. And that stayed alike in the answer. Remember, what's alike stays alike in the answer when it comes to addition and subtraction. So these are like terms. So think of it this way. When you see this first problem, the 4 square root of 6, this is like saying 4x. And this is like saying 7x. Like they're both x because they both are the square root of 6. So we're going to use similar rules as we did when they were just x's. So these are considered like terms because they have the same numbers inside the radical and the indexes are the same. So because they're like terms, we can add the 4 plus the 7, and then what was alike stayed alike in the answer. So it's actually 11 times the square root of 6. So the same thing happens here. These are the square root of 3, square root of 3, so they're alike. So we can say 2 plus 8 is 10, and we have the square root of 3. Not too bad. Then we come down here to the next one, and notice here it's 10 times the cube root of 5 minus 4 times the cube root of 3. Now they have the same index, but they don't have the same base. So you can't do anything to this. That would just be the answer. We'd just write that whole thing all over again. And then here we have one that's quite a bit larger. Let me back off a little bit so you can see it. 9 times the cube root of 3x plus 2 times the cube root of 3x minus 10 times the fourth root of 3x. So we want to make sure we only combine like terms. And so yes, these are all 3x's, but the indexes, see them? These two are the only ones that are alike right here. So we can put these two together. We can say, well, we're going to have a cube root of 3x. And how we put it together is we take the numbers that they're being multiplied, 9 and 2, and we add them. So I have 11 cube root of 3x. So these were taken care of. We combined them. And then we still have this one we couldn't do anything with, so we're just going to write it as is and not change it at all. So this would be our final answer. So, you know, we might have something that could be simplified, but we haven't yet, we can't see it yet. So it's, can we make them alike? And so the square root of 8 could be thought of as the square root of 4 times 2. And the square root of 4 is 2. So we would say 3 that we currently have times 2. And in the radical we have square root of 2. So the square root of 4 came out here and joined the 3. So this becomes 6 square root of 2. Now over here, this could become square root of 16 times 2, because we know the square root of 16 is 4. So then this becomes minus 4 square root of 2. And sure enough, when we were simplifying each of these, we found something that they had in common, that's alike. So we keep this part, what's alike stays alike in the answer. And then 6 minus 4 is 2. So there's our final answer.